emergency traffic lights using RF module. As we know that there is a lot of traffic problem nowadays, because of this, ambulances or emergency vehicles cannot reach their destination in time. So to solve that problem, we have come up with this idea. Now, this is the basic block diagram of our project. So what happens is that what will happen is that each ambulance is gonna have these 4 switches, and they'll be designated a proper directions, supposedly north, south, east and west. Here we've used 1, 2, 3 and 4. So what will happen is when there's an emergency, the radio frequency signal will be transmitted by activating the switches. The switches will be activated at a particular voltage of signal which is produced, and it will be encoded, and this encoded data is given to the data pin of the RF transmitter, and to establish a serial communication between the transmitter and receiver. After establishment of the connection, a signal of frequency 433 megahertz, because we're using 433 an RF transmitter of 433 megahertz, it will be transmitted the encoded data to the receiver, which is connected to the microcontroller through decoder, which decodes the received data signal. So when an emergency mode is activated, it gives a green signal to that particular direction and sets red signal to all other roads or directions. So this is the block diagram. The transmitter switch, the encoder, the RF transmitter, the RF receiver, decoder, and the Arduino, that is a microcontroller, and these are the lights L1, L2, L3 and L4. Now we decided to use RF module was because we could have used other options like Bluetooth, Wi-Fi or nRF24, but why we didn't use that? Because Bluetooth can be a bit excessive if we just want to send a bit of data from our sensor or keyboard, and Wi-Fi can also be a bit excessive if we have basic requirements, and it can also cost a bit of money, and it also needs to be authenticated onto our network properly. And we didn't use nRF24 because it is a little tricky to implement and we don't really need two-way communication, so it was gonna be a little excessive. That's why we have used RF module. Now RF module is cheap, it has one-way communication and it covers a reasonable distance. Now there are basically 3 different methods of sending digital data with radio frequency. The 3 ways are, one is FSK, that is frequency shift keying. The second is PSK, phase shifting keying, and the third is ASK. ASK is amplitude shift modulation keying basically. So what happens is, in FSK, the digital signal modifies the frequency of the carrier wave. In PSK, that is phase shifting keying, works by modifying the phase of the carrier, and in ASK works by modifying the amplitude of the carrier wave. So we will use ASK. The amplitude shift keying is sometimes also called binary amplitude shift modulation, as there are only 2 levels to be concerned with: the digital 1, which drives carrier at full strength, and the digital 0, which cuts the carrier off completely. Now ASK has the advantage of being very simple, so the resulting circuitry is simple and inexpensive. And the disadvantage is that ASK is susceptible to interference from other radio devices and background noises, so that's one disadvantage. And now, why is the encoder and decoder used? Encoder and decoder, what they basically do is they convert parallel data into serial data. So, okay, so what is parallel data and serial data? So basically in serial transmission, what happens is that the transmission, the data is sent bit by bit one after another. So serial transmission is used for long distance data transfer. It is also used in cases where the amount of data being sent is relatively small, and the circuit used in serial transmission is simple. So yeah. So basically, what the encoder and encoder converts the parallel data into serial data, and the decoder converts the serial data into parallel data. So, and after the encoder converts the parallel data into serial data, this data is then given to the data pin of the RF transmitter to establish a serial communication between the transmitter and receiver. And after this, it sends the signal, and when it receives the signal, the decoder converts the signal from serial to parallel, which then it sends to Arduino, that is the microcontroller, and which further controls the lights. Now our traffic junction this is a block diagram of the circuit in the traffic junction. So basically our microcontroller will be connected to the power supply, and our receiver module will also be connected to the microcontroller, that is Arduino Atmega 2560, and this will further be connected to the lights L1, L2, L3 and L4, which is a light junction. This is the transmitter module. As you can see that these are the 4 switches. This is the encoder H12. This is encoder H12E, and this is our transmitter, RF transmitter, and this is an LED use. So we've turned on the transmitter. So this is the transmitter section over a single channel, like this is the example this, and in parallel transmission sends multiple data bits at the same time over multiple channels.
This is the receiver section of our project. The signal is received to the RF receiver, which is right over here. The receiver module has 4 pins, namely VCC, D out, linear out and ground. VCC is powered by a 5-volt supply, and the operating current here is less than 5.5 milliampere. The pins D out and linear out are shorted together to receive 433 MHz signal from the air. The signal is then demodularized and sent through the data pin. Further passes on to the resistor, which is right over here, which is also connected to the oscillating terminal of the decoder. This is basically to enable oscillations. The decoder here converts the signal from serial to parallel and passes it on to the Arduino Mega. We're using Arduino Mega instead of Arduino Uno due to the high number of pins in Arduino Mega. Since in our traffic light system there are almost 12 LEDs, so we need each pin for each LED, hence the reason that we're using Arduino Mega. This screen over here depicts the state of the traffic lights. As if the lights are running normally, it will depict a normal sign over here. But as soon as there's an ambulance approaching and we press any of these buttons on the transmitter, depending on the direction we're approaching from, the lights will change according to the transmitter and the direction we're coming from, and also over here it will depict which lane should the lights go right. Seems like a bit of mess because all of these are not, the receiver part is not actually connected, but it was due to we ran into some troubles and we couldn't complete it. We couldn't actually get it together on time.
So now coming to the coding part, firstly we will include the library required for the LCD liquid crystal, and we have assigned values with the 8, 9, 10, 11, 12 and 13. So here is A8, A9, A10 and A11, which will be receiving data from the receiver, and similarly we have assigned different variables for different lights in different lanes, like L1 green is assigned for green, L1O is for orange and L1R is for red for lane number 1. So this is whole triad for lane number 1. Similarly for lane number 2, green, orange, red, lane number 3 and lane number 4. So clearly the pins are 16, 15, 14 for L1, 17, 18, 19 for L2, 2, 3, 4 for L3 and 5, 6, 7 for lane number 4. Now we are giving code that is checking for the inputs and outputs. The inputs we are giving is through S1E, S2E, S3E and S4E, and we are getting outputs on the following lane wise variables. Now further it is continuously checking that what type of operation is being operated on the LCD part. Firstly LCD will clear, then we will set the cursors to 0, 0, then there will be printed traffic light and control during, set cursors 0 to 1 se ho jayega. And so here are few basic codes which are required for the natural running of the LCD display, and here is the code for the first lane, second lane, third lane and the fourth lane with all the digital write commands. So here is a situation when no ambulance is coming, so it will check S11E is 1, S12 is also 1, 13 is 1 and 14 is also 1. So the lights will be interchanging between red and green in the natural time intervals. So with the condition when the ambulance comes at the first lane, S11E comes at the 0 and L1G becomes high with a delay of 100. When the second lane, similarly L2G becomes high, at the third lane L3G becomes high, and at the fourth lane L4G becomes high with a delay of 100. And that was the coding part. Thanks a lot.